Welcome to video 6 on the FCEditor Complete Guide series, where I'll be explaining everything you need to know about making custom Future Cop levels in FCEditor. For this video, we'll be covering the bulk of actors. There's a lot to talk about here, so buckle up and let's get right into it. Actors are game objects. Everything that isn't level geometry is an actor. Triggers are an actor, the player is an actor, even the particle effects are an actor. To view and edit actors, we'll need to switch to Actor Edit mode. Clicking into this mode, we can now see all the actors that are present in the level. Most actors will render objects that are attached to them, but some actors don't have objects. These actors will display a sprite instead. Going through the level, we can see that there are many different kinds of actors. There are props, turrets, pathed actors, triggers, all sorts of different actors can be seen in the level. Editing an actor can be quite complex, so let's just start with moving an actor. To move an actor, we first need to select the actor by clicking on it. The actor will have a highlight around it, and some colored lines will appear inside the actor. These lines are for moving an actor in a specific direction. Simply just click on one of these axes and drag the mouse to move the actor. The actor can also be moved in a more quicker way by holding left shift. This will cause the actor's position to jump to the cursor's position. When moving an actor with the cursor, the position can be locked to a grid by holding left alt. Notice how no matter where we move the actor, it always seems to be glued to the level. Even actors that seem to be floating are also influenced by the level. This is because actors don't have a typical axis used for height. Instead, it is attached to the level and can have an offset from the ground. The editor calls the actor's attachment to the level a groundcast. There are 4 different types of groundcasts an actor can have. The first is highest, which means it will attach to the highest point on the level. Second is lowest, which will attach to the lowest point on the level. Third is middle, which will find a middle area on the level. And last is no cast at all. It will default to the 0 position. From this groundcast, there can be an offset that the editor calls a height offset. Whatever the position is in the groundcast will be offset by a certain amount. Not all actors have a groundcast or height offset, but many do. These values can be found in the actor property view, which we'll talk about here momentarily. Actors that do have an offset can have it changed by dragging the green axis. Moving around actors is only a scratch on what can be done. You may have noticed this side view that will change information depending on what actor we select. This top area is called the property view. Actors have many properties that can be modified and tweaked to change the actor's behavior. It also allows us to change other properties such as object references, scripting, and spawning. Let's try to see if we can modify some properties on this turret. When selecting an actor, we can see the name, the ID the actor has, and the actor behavior. Actor behaviors are an actor type that have specific functionality and properties. The behavior for this actor is a stationary turret. Next, we can see some groups here that hide actor properties. If we click on one of these groups, it'll expand all the properties within them. Here we can start changing different properties, but before we do, notice the names on the groups. We have groups for entity, shooter, and turret. Let's try a different actor to see what property groups it has. Wait, this actor also has the same entity, shooter, and turret groups, even though it has a different behavior. Let's try another one. Now this one only has the entity and shooter. What's going on? Well, behaviors work in a concept called object hierarchy, which means that behaviors can inherit other behaviors and gain their properties and functionality. This works in a chain of behaviors inheriting each other until it reaches a final behavior used by the actor. So, for example, stationary turret inherits from turret, which inherits from shooter, which inherits from entity. Let's break that down to what each inherited behavior does. The entity behavior is the base behavior for many actors. It allows the actor to interact with the world and other actors. Entities have functionality such as health, which means they can be destroyed or killed. The shooter behavior inherits from entity and provides functionality for targeting and shooting other actors. The turret behavior inherits from shooter and controls how the objects respond to the shooter behavior. The turret behavior controls the object's rotation, turn speed, height offset, and other behaviors relating to its objects. And finally, we have the stationary turret behavior, which utilizes all these behaviors and adds the new functionality of giving the turret a base object to rotate on. There are 4 behaviors that actors can inherit from: Entity, Shooter, Turret, and Path Entity. Path Entity is a very specialized behavior allowing the actor to use navigation meshes. The next guide video will go deeper into path entities and navigation meshes. Going back to our turret, instead of modifying properties for one behavior, we're actually modifying properties for all 4. Now, as you can imagine, this means that there are a lot of properties. If I were to go through every single one of them, this video would never end. So instead, I've made a document that describes all known properties in detail. Don't worry about understanding what all of these do. It's best to either leave them as default or utilize actor schematics, which I'll explain later in this video. Although I can't go through every single property, I'll briefly point out the ones that are commonly seen in actors. Tags are a bunch of toggles that alter the actor's behavior in some way. These can be minor from giving it a shadow, or they can provide large shift in actor functionality. As mentioned, you'll want to look out for any ground cast or height offset properties that control how the actor is positioned in relation to the level. Shooters reference a weapon actor that is used for the projectile. A lot of behaviors expected in a shooter are actually coming from the weapon actor. Changing rotation for actors will be a slider from -360 to +360. You can lock the slider to increments of 5 by holding Shift. Some actors have editing nodes that allow for a more intuitive way to edit properties. For example, with map nodes, it will show the position of all the nodes that can be moved like an actor. Or with elevators, it will show the ending positions. Remember to check the document to see what all these properties do on actors in detail. Moving on from behavior properties, let's look at the other section the property view has. The reference section is what actors use to reference essential assets. These are almost always going to be objects with the exception of navigation meshes used by Path Entity. We can click on one of these references to change to a different asset. This is the section to use for changing objects on actors. When it comes to modifying actor objects, it's important to understand key positions. Key positions are vertices on objects that are marked as important. Actors use these key positions for things such as the placement of turret heads or the position on where to shoot a weapon. Most existing future comp models are already going to have key positions, but for custom models, the actor won't place its objects correctly. To see these key positions, we'll need to open the Asset Manager and edit an object. Once in the object editing scene, a panel on the right can be seen listing key positions. There are a maximum of 4 different key positions, with each one showing an index of a vertex. If the index is 255, then the key position is invalid. We can click on the Reset button to set the key position to invalid, or we can hit the Set button that will allow us to select a vertex to be a key position. Going back to the property view, the next area is the scripting. Actors utilize scripts through callbacks, meaning it will trigger a script to run through an event like getting hurt or being destroyed. The 3 most common callbacks are on hurt, on death, and on new second. On hurt will trigger if the actor takes any damage of any kind. On death will trigger if the actor is destroyed. And on new second will trigger every second. The new second callback will only trigger if the toggle Enable Third Callback is checked. There are other kinds of callbacks with different actors, like the triggering actor having an on-trigger callback. With each callback, we can see the current script selected, along with 2 buttons. The code button is for setting a script on the callback, and the pencil button is to edit the script on the callback. We'll talk about the scripting panel in another video, so for now, let's just close this out. The next area in the property view are the spawning properties. All actors have the option to have special properties controlling how the actor will spawn in the level. If an actor has no spawning properties, it will spawn immediately when the level loads. If the actor does have spawning properties, then it will utilize whatever properties before the actor spawns. The actor will not spawn when the level loads unless told by script. Spawning properties also gives the actor the ability to have copies of the same actor. This is useful for large group of enemies like tanks, infantry, or aircraft. Going through the properties, the first one we have is respawn time. This is the time it takes for the actor to respawn after it has been destroyed. This is also the time it takes for the actor to spawn in for when the first time the level loads. Next is random first spawn. I'm not sure what this property does exactly, but what it appears to do is have a random time for when the actor first spawns in. The next is max active actors. This is how many actors can be active at a single time. For example, in Precinct Assault, each tank and chopper have a maximum of 20 actors. Disable respawns will prevent the actor from respawning. Max respawns is the amount of times the actor can respawn with the option to have infinite respawns. At the bottom, there is a button to remove the spawning properties altogether. This button will add the spawning properties if the actor doesn't already have them. These areas in the property view are everything needed for modifying actors. But what about adding new ones? This brings us, finally, to our first tool in the edit mode, the Add Actor. If we click on this tool, we're presented with a list of all the different kinds of actors. After selecting one, a green arrow will point to the level following your cursor. This is where the new actor will be placed. To place the actor, simply click. Depending on what actor you placed, you may be greeted with a red cross. This means that the actor is expecting an object, but because we just added it, it has no objects. We'll need to quickly assign it objects in the References section on the property view. This red cross will also display if an object was deleted that was used by an actor. It's important to fix these issues before saving a level, as future cop will crash if it has any actors that are missing objects. With the newly added actor, we can now use the property view to tweak the actor. If a property is unknown or you're unsure what it does, leave it as default. While this is useful for constructing entirely new actors, many times we'll just want to reuse the same actor, especially for actors such as props. This is where a very familiar view makes its way into actor edit mode, Schematics. That's right, the level schematic view in Tile Add mode also makes its way into actor edit mode, only this time with actors. To save an actor as a schematic, first select an actor and click the Add Actor Schematic tool at the top. To view the actor schematic, click the Open Actor Schematics tool next to the Add tool. Here we can see the actor schematic that we just added. To place an actor from a schematic, simply click on the item and then click on the level to place it. If you'd like to place multiple actors at a time, hold down Shift to prevent the schematic from deselecting. After the actors have been placed, we can right-click to end schematic placement. Going back to the actor schematic view, we can organize and manage all these schematics. Right-clicking on a schematic will give us the option to rename the schematic or delete it. Schematics can also be moved around by dragging and dropping. At the top, there's a button for adding a folder which we can drag and drop schematics into. With folders and dragging, actor schematics can be organized in all sorts of different ways. Because of how complex actors can be, I recommend utilizing schematics to copy over actors from other levels. Actor schematics are a part of presets and can be saved to a preset file. You can also save schematics and add actors that are unsupported by the editor. We can now both add and modify actors, which is all we need to jump straight into making all sorts of custom actors and levels. But before we do, we need to first talk about how to manage all these actors. Actors can really add up, and there can be hundreds in a level. Trying to find and manage all these actors can be tricky, but luckily there's a dedicated view for this. The bottom section of the right panel is the Actor Scene view. This view shows a list of all the actors that are currently in the level by name. Right now none of these actors are named, so it defaults to the name actor and their data ID. The view will highlight the selected actor, and we can even select actors with this view by clicking on them. With a selected actor, we can have our camera jump to the position of the actor by double-clicking. Selecting and jumping to actors doesn't help us a whole lot if we don't even know what these actors are, but with this view, we can name these actors and group them in special ways. If we right-click on an item, we're given the option to rename, group, ungroup, or delete the actor. With rename, we can now set a name for the actor that can actually have some meaning, And with the delete, we can of course delete the actor. Actors can also be deleted by hitting the delete key when selected. The group and ungroup are for changing the actor's positional grouping. The actor scene view groups actors together if their positions are the same. Many times actors will have the same position, and this is a way to select the intended actor. Groups in the actor's scene view will show a folder icon that can be extended to see the actors inside. Groups can also be given unique names, like with actors. If you select an actor in a positional group, moving one will move all other actors in that group. To create a new positional group, right-click on an item and hit Group. A text pop-up will appear asking to select the actor to group with. Once an actor has been selected, it will cause the original actor to jump to the selected actor's position and create the group. Actors can also be ungrouped by right-clicking and hitting the Ungroup option. This context menu will also appear by right-clicking on the actor itself. While we can use the option in the context menu for grouping and ungrouping actors, there is a much better way to positionally group actors in the actor's scene view. Like with schematics and presets, we can click and drag on one of these items to move them around or put them into groups. Remember that anytime you group an actor, it will change its position to be the same as the group. By default, the actor scene view will show all the actors in the levels and actors grouped positionally, but there are a couple ways that we can customize this view. On the header, there will be a dropdown for choosing to sort actors by either their position or by their behavior. If we choose the behavior option, we can now see all actors are put into groups by their behavior. These groups are automatically made by the editor and cannot be modified. Switching back to positional, there is a search bar where we can type to find a specific actor. This can be useful in finding out what an actor is if referenced by another actor or via scripting. Lastly, there is a menu on the right that can allow us to choose which actors will appear in the actor's scene view. This is a way to declutter the view from all the props or static actors. That covers the bulk of actor edit mode, though there are a couple miscellaneous things to talk about with actors. The last tool in this mode is to open the supporting actor data panel. This panel contains special data that is used by some actors. The first data here are teams. Teams are an identifier actors can use to group actors together for things such as attacking. The property for setting an actor's team can be found in the entity behavior. Here we can add a new team or manage existing ones by right-clicking. Next is script groups. Script groups are very similar to teams. This identifier is commonly used to reference a group of actors in scripting. Script groups will be talked about in more detail in the scripting guide. The last data here are texture snippets. Texture snippets are used by a specific actor called the texture behavior. These actors are flat planes that render a texture. They do not interact with anything in the level, and they're there just to enhance the level's visuals. These actors are commonly used as fog effects or for billboards. The actor does not store the texture data, instead it references a texture snippet. In the Texture Snippet tab, we can see all the textures here that the texture actor can reference. These textures can be modified and new ones can be added as well. Right-clicking on a snippet will give us the option to edit, rename, or delete. Hitting the Edit option will bring up a specialized UV mapper for changing the texture. And that is Actor Edit mode. Actors can be tricky to work with because of the complexity of properties and behaviors. It's best to try to find existing actors to use as a reference and build from there. If you're having trouble with actor properties, remember to check out the doc to see what they do. We covered a lot with actors, but we're not quite done yet. Paths entity is an actor behavior that utilizes nav meshes, which the editor has an entire mode dedicated to nav meshes. In the next guide video, I'll be talking about paths entities and navigation meshes. If you have any questions or would like to see more Future Cop, consider joining the Discord linked below. I'll see you in the next video on navigation meshes.